So there are lots of physics applications that use the difference quotient. So when they say A, what is the velocity of the ball after 5 seconds? Since they just mentioned that one point, we are looking for the instantaneous velocity at 5 seconds. So what we need is the slope of the tangent at 5 seconds. So that's what you need to know what they mean. So first thing we have to do is find a slope of a tangent for this particular function. So remember, that's the limit as h approaches 0 of f of x plus h minus f of x all over h. Now they called the function s. It doesn't matter. It's just, we'll put t's instead of x's. But if we take the function and we plug in, let's just keep it x's, x plus h. We get 4.9 times x plus h squared. And then if we plug in x, we get 4.9 x squared. Now remember, x plus h is, when we square it, it's x squared plus 2xh plus h squared. I hope you just know that by now so that you never forget that middle term. There's that 2xh there. Don't try to square the inner quantities. It is x plus h times x plus h. You have to FOIL it. It is a binomial distribution. You have to FOIL it. Okay. So let's put in everything we need for our formula. So this is going to be 4.9 x squared plus 2xh plus h squared minus 4.9x squared. Now, if that was more than one term, I would definitely put it in parentheses so I remember to distribute the negative. But it was only one term, so that's good. Now, remember, if we did it right, anything that does not contain a h should cancel out. Now, the only thing that does not contain an h is the 4.9 x squared, and there is a negative 4.9 x squared in the problem. So then the only terms left are these. They're divisible by h, so let's divide it. Save ourselves a little bit of room here. When we do that, we get 9.8x plus 4.9h. Now we're taking the limit as h approaches 0, so only the h becomes a 0 at this point. So the formula for our slope of our tangent for this particular function is 9.8x. They use t, so now let's bring the t's back into it. So the slope of the tangent at any point, so the instantaneous velocity at that point would be 9.8t. So the answer to A is at 5 seconds, it's 9.8 times 5. And 9.8 times 5 is 49 feet per second. So at the exact time of 5 seconds, it is traveling off of the tower. If we dropped it from the tower, it would be going 49 feet per second at that exact instant, okay? Oh, I'm sorry, meters per second. Thank you. Thank you. Okay. So B says, how fast is the ball traveling when it hits the ground? So there's a few different things that we have to figure out for B. Okay. So the first thing you want to think about is what time does it hit the ground? okay? So if it's 450 meters above the ground, we need to think about where has it gone 450 meters? How long does it take for it to go 450 meters? So if we solve for time, we get t squared is 450 divided by 4.9. So t would be the square root of that. The reason we don't need the plus or minus is because it's a time. We're not going to go backwards in time. We don't have a time machine, last I checked. True, I do not have a time machine. And that's the square root of that entire fraction, Lucility. That's the square root of that fraction, which is approximately 9.58 seconds. So the speed at the ground, we have a nice formula for that instantaneous rate of change now, don't we? We know that the slope of the tangent at that point is 9.8 t. So in this particular case, it's just going to be 9.8 times 9.58. Which would be 93.884 meters per second. So there's lots of physics applications that you are going to see depending upon the particular function, and but you'll see for if it's given in meters, you'll see 4.9 and 9.8 appear a lot, because the gravity is 9.8 meters per second squared. If you if we're dealing with feet, you'll see 32 and 16 for the same reason, because of gravitational pull. Okay, so that is a little example there about some physics stuff. Do we have any questions about that one? Kind of makes sense, maybe a little bit. Now, here's where we learn the term derivative. It's just the slope of our tangent. So we need to know that the slope of the tangent is the first derivative. So if I say find the slope of the tangent, or if I say find the first derivative, it's the same formula, same thing. They're exactly the same. So it's just a language. You have to know that this little notation, that little prime notation, f prime, is the derivative of f. You just need to know that notation. That is not a power. That is not anything funky. It's just a little prime notation. That's just the notation that means find the first derivative, find the slope of the tangent. So f prime of a is the slope of the tangent at a. So you'll notice instead of x's, they've used a. So it is the first derivative. That notation, I will say, find the derivative. Now, eventually we'll have some shortcuts. This is the longest way we'll ever do the derivative. There's tons of shortcuts. And I will teach you all those shortcuts, and you'll have to memorize them. For now, we got to practice doing the long way before we do the short way. You got to walk a little bit before you can run. But I will show you the shortcuts. There are some nice shortcuts out there that we'll get to. I think as soon as 2-3, maybe. I'm not sure. Maybe even 2-2. But yeah, we'll learn some shortcuts for the derivative, so we don't always have to do the difference quotient. But the difference quotient is going to give us the slope of the tangent, which is our derivative. Okay. So just know the language. We will put that as one of our next vocabulary words. If you didn't do the vocabulary yet, I don't know what I did with the video. There's no video. Yeah, we did the vocabulary. If you haven't done the vocabulary yet, I did provide a PDF. You're just going to have to copy it. I don't have any video. I'm sorry. I think I deleted the video accidentally. But I provided at least the PDF copy for you, okay? Maybe one day if I'm motivated enough, I'll make a video for it. Eventually, yeah. So we'll do all the vocabularies together, and hopefully next time I won't delete the video. Because I'm almost positive I made a video on it. Anyway, it's one of these years you guys get to put up with me. Okay, so anyway, it says find the derivative of the function f of x equals x squared minus 8x plus 9 at the number a. So they're really saying find the slope of the tangent when x equals a. That's all they want you to find. Okay. So remember, the derivative is just our slope of our tangent at a, which is the limit as x approaches a of f of a plus h. No, that's not right. That's the other formula. The limit as h approaches 0 of f of a plus h minus f of a all over h. So to the side, let's do f of a plus h and f of a. That's why it's so important that we know how to do that. If we plug in a plus h, watch what happens. All of the x's are replaced with a parenthesis containing a plus h. Now, don't make that harder than it is. You guys want the f to somehow be involved. No, that just tells you what function you're using. We're going to use the f function to plug in a plus h. Okay. Hopefully you know this by now. That's a squared plus 2ah plus h squared. Let's distribute the 8, well, the negative 8. And now we got our little list of what f of a plus h is. And now let's find f of a. We're just inputting a instead of x. That's the easy one. That's just a squared minus 8a plus 9. Now let's put those into our function. So f of a plus h, we're going to write this whole thing and put it in that location. So that's going to be a squared plus 2ah plus h squared minus 8a minus 8h plus 9. Now we are going to subtract off the f of a. So you can do it one of two ways. You can put a minus, and then you can put the f of a in parentheses after it. Or we can just subtract a function is to list its opposite. We'll add the opposite. So it's going to be minus a squared plus 8a minus 9 all over h. Okay. Now remember, if you did it right at this point, everything that does not contain an h should have an opposite appear in the problem. So a squared and negative a squared, perfect. I see a negative 8a and a positive 8a. I see a positive 9 and a negative 9. All the other terms contain an h. So at this time, you can do it in a second step, but why not cancel and divide by h? So f prime of a is the limit as h approaches 0 of 2ah divided by h is 2a. H squared divided by h is h. Negative 8h divided by h is negative 8. And now, since that's such a nice quantity, we're allowed to just substitute in 0. So the only thing that becomes 0 is this. The other things are just going to come along for the ride. So our formula is 2a minus 8. Now, once you know the shortcut, we won't have to do this anymore. So there is a way that we are going to do these eventually where we don't have to do all that junk. But for now, you have to know how to use the difference quotient. Now, for a polynomial like this, the algebra will just lead you to it, but you do have to multiply all the junk out. For a square root, we're going to use the conjugates. For a fraction, we're going to use the common denominator. So those are the three kinds that are most common. So for a polynomial, just multiply it all out and simplify. For a square root, use the conjugate. For a fraction, we have to use the common denominator. That's really the three that you need to know. Okay. Let's talk about finding the equation of a tangent line. The derivative is the slope of the tangent. So if I asked you to find the equation of a tangent line, you're going to find the derivative. That's just a fancy way of saying finding the slope of the tangent. Well, the equation for the slope of the tangent. And then step 2, you'll plug whatever number is in so you can actually find the slope. And then we use our point slope formula and we got it. Okay. So the derivative, remember, is just an equation for the slope of the tangent. So then step 2, you just plug the number in to find the actual slope. And then 3, you use the point and the slope to find the equation of the tangent line. So you need to know those 3 steps. From now until May, you always need to know how to find the equation of a tangent line. It's not going anywhere. It's an important part of this course. That's a general Calc 1 thing that you have to know. Okay. So again, you're going to find the derivative equation. You're going to then plug your number in to find the slope. Once you have a point in the slope, it's like any point in slope. We just use the point slope formula. Everybody done with that? Okay. So let's actually do example 6. Now, do you recall the equation that we see there? Remember in example 5? It's the same thing, right? So we found, for example 6, step 1, that our derivative at a, wasn't it 2a minus 8? Is that correct? Yeah, same exact equation. So we don't have to do that part again. Okay. Okay. Yeah, same exact equation. Okay. Now, our a value is 3. So in the second step, if we do the derivative at 3, that's just 6 minus 8 or negative 2. That is our slope of our tangent. So the derivative equation gives us a way to find the slope of the tangent. Then step 2, you just plug your x in this particular 3, to find what the actual slope value is. And then step 3, we're going to use the slope that we found. We're going to use the point that was given, and we're going to use y minus y1 equals m times the quantity of x minus x1. We're just going to plug that in. So it's going to be y plus 6 equals negative 2 times the quantity of x minus 3. Now, I'm okay with you stopping there unless the instructions say to put your answer in slope-intercept form and then solve for y. To solve for y, it's almost always the same procedure. Distribute your slope, move that number. So, I mean, hopefully that's not anything surprising to you, okay? So those 3 steps become super important that you know. because that's just an essential thing that you need in a calculus class. Okay, everybody good with example 6? Okay. Let's look at example 7. No, we're not going to do example 7. So now your answers are, or your problems are the odds that we see from that list from the book. So for the remainder of class, if you could please work on this homework, that would be great.